Hey, Precalculus, we're going to tackle section 5.6 today on solving logarithmic and exponential equations. We're going to use a bunch of tricks to solve equations. Look, this is just straight up algebra today. Looks intimidating, but I'm going to show you some tricks that we use, and you're going to see some patterns. One thing you guys are all very good at is recognizing and repeating patterns. So, although I think the notation is weird for you, and recognizing the rules the first time is going to be a little bit of a stretch, I think you're going to be good at this, okay? So here are the 4 tricks we use to solve these kind of equations. Rewrite from exponential to logarithmic form. Or the other way around. Actually, just rewrite the thing, and then you can be able to solve. Set the arguments equal to each other. I keep saying that word. That's the stuff inside the parentheses. Like this x plus 2 right here is an argument. Okay? A third trick that we like to do, take the log of both sides, because logs have some unique properties. And then number 4, factor. What? Factor one side of the equation. Okay? I'm going to rip through 2 examples here, and then I'm going to have you do 2 on your own. There might be extra videos today. Here we go. Trick number 2 is the first one. We're going to set arguments together. Ready? I got a log. I got a base, I got a number right here. I want to just kind of set things equal. We did this with exponential equations earlier in the chapter. Before I can do that though, this 2 is a problem. So I'm going to use the trick of logarithms to rewrite this as the log base 5 of x squared is equal to the log base 5 of 9. Now look what I've got, log base argument. If you want, I'll put parentheses around them so you can't mess it up. Log base argument. Then I just get to go x squared equals 9. So x equals 3 and x equals negative 3 should be my answer. However, every time you solve a logarithmic equation, you got to check to see if you can put in numbers. You cannot use a negative number for a log. You don't have to put this in your notes if you don't want to, but the logarithms have x equals 0 as the vertical asymptote. There is nothing over here. You can't put a negative in, so that x equals negative 3 is referred to as an extraneous solution. It's got to go. Your only answer is x equals 3. You have to check your answers with every logarithmic equation. Got to do it. Okay, the second one. You guys are going to do your own. I'll start it though. I would like to rewrite this as the log base 2 of x to the third. And this one, that negative, I got to put that up here too. So I'm going to go log base 2 of 27 to the negative 1. See what I did there? And you guys are going to finish that off on your own. Solve each trick. This will be trick number 1. Rewrite exponential logarithmic form. Look how different this is. Log on both sides of the equation. Log on both sides of the equation. There are only logs on one side of this equation. And so that's how I know I'm going to do trick number 1. I'm going to rewrite. So look, I can put this together with my properties of logs from section 5.5. I can write this as log base 5 of x plus 6 times x plus 2. And that's equal to 1. Then now look, I can rewrite this as an exponential equation. The base of the log is the base of the exponent, and these two things switch places. Right? No more log. I've rewritten as an exponential equation. And 5 is equal to x squared. This would be plus 2x plus 6x. So plus 8x plus 12. Then I'm going to subtract. You guys should be experts at this. 12 minus 5 is 7. I'm going to factor this. I get x. Well, it's 2 things that have to multiply to give me a 7. There's a 1 and a 7. They got to be the same, and I want them to be at 8. Isn't 7x plus 1x equal to 8x? So I get x equals negative 1, and I get x equals negative 7. That should be my answer. But every time you got a logarithmic equation, you got to check the answers and make sure they make sense. You can't have a negative inside the argument. If I put a negative 1 in here, I go negative 1 plus 6, and I get 5. Oops, I'm up here, sorry. Negative 1 plus 6, I get 5. That's okay. Put a negative 1 here. Negative 1 plus 2 is 1. That's okay. The negative 1's actually okay. It's not that the answer can't be negative. It's that the argument can't be negative. Put in a negative 7. Negative 7 plus 6 is negative 1. That's out. So my only answer here is negative 1. Okay? I'm going to start this one off for you too, just like I did the last one. This will be the log base 2 of x plus 7 times x plus 8, and it's equal to 1. You guys finish that one off.